So the first time I tried to write it backwards, this time I wrote it forwards, but I can never tell if it's gonna turn out right or not. So I'm gonna go over vaccines. We have natural and artificial immunity. Natural is you're born with it, artificial is you get vaccinations and such. You'll have two types, like an active and a passive. The active is gonna last longer because it's more detailed, and then the passive is like more general, like it's always around, but like we can get more into that. So for vaccines, you have killed versus live vaccines. The killed ones are, well, you have a lot of different types. There's also subunits where they take a part of it, which is the best kind because you have the least amount of side effects, but it's also the most expensive to make, so it's not ideal. Live attenuated vaccines are like a weakened strain of whatever it is. It's usually a bacterial type of organism, and they'll give that for a bunch of diseases. And so the subunit type is a purified macromolecule vaccine, and they also have one other, they use the epitope, which is the functional part of the bacteria that you want to match. Right, so purified. Live, you get better defense because it's closer to the actual organism because it's from that. The only risk is 1 in 4 million of it having, like, activating and becoming the actual virus or pathogen or whatever it is. The killed versions, they call them inactive or I think just killed. They're a bit safer, but you have to get boosters for them because your immunity kind of forgets and it wears off. So an example would be like, I can't think of an example. I was gonna say tetanus, but I'm pretty sure tetanus is a toxoid, but you have to get boosters for tetanus every 10 years too. Measles is a live virus vaccine. Chickenpox is live attenuated, but if you have Shingrix, it's a recombinant vaccine for shingles later because it's the same kind of virus, progressed differently. Okay. Polysaccharide vaccines are commonly conjugated to inactivated proteins. I would say if they mention polysaccharide, it's usually because it has to do with your humoral response, which is just your B cells. When it starts getting peptides and proteins, that's when the T cells get involved, and that'll give you better memory for it in the future. Herd immunity, a lot of people are vaccinated, so the disease kind of just goes away in that population. Let's see. Oh, immunocompromised patients. So that's going to be pregnant, if they have a suppressed immune system, like they just had a surgery and they're trying to suppress the immune system to accept a graft or an organ transfer, or just like chronically ill immunosuppressed people, should not get live vaccines. Their body cannot handle it. It's not worth the risk. They can have the killed vaccines or other versions. Side effects and risks of vaccines. For example, reasons vaccines are contraindicated in some patients. I feel like I just mentioned that, but let me see if he says anything different. Jump around. If someone's allergic, don't give them a vaccine because they're allergic. Oh, measles, mumps, rubella is live. Other adverse reactions. You could get, they're not terribly common. Fever, pain, allergic reaction. And if you have an allergic reaction to a vaccine or a vaccine component, it's rare and should be reported to the CDC. but the side effects are usually rare and easier to deal with than the actual disease. So don't give it if they are pregnant, immunodeficient, or have chronic medical conditions. So that would be like your asthma, diabetes, kidney, heart problems, but that's up to the patient and physician. I did say that. And so he liked to mention in his thing that they're working on DNA vaccines because it's going to be cheap and effective, but we also have RNA vaccines, which are fidaxomicin, which is its own type of category drug, and it's only the brand name is available, so that's why it's kind of like not sure if you want to prescribe it to a patient if they can afford it, because it's marketing kind of thing. And there's one other, RNA rifampin, because rifampin is an rRNA vaccine, and the rRNA vaccines are how they made the COVID-19 vaccine. And I mean, I think that's what I've got. Tetanus requires boosters. I did say that. Oh, live vaccines. The first dose you get covered. The second, inactivated vaccines, the first dose won't really provide protection, but like second or third one would. And then that's where the titer goes down over years. Blah, blah, blah. Look at that. Killing it. Rabies vaccine is a killed version. Polio. It has a Salk, S-A-L-K. That one's the killed version, but there's also Sabin, which is the live version, but they discontinued that because there was a worry about like the oral fecal route of it like getting into the sewage system and infecting other people in a city if someone had that. So I thought that was a fun little thing. It wasn't in these notes, I just learned it. But, and then I gotta figure out what these bacteria are and the types of vaccines that we can give them. But yeah, tetanus, toxoid, called it. Pertussis, you give them DTaP, diphtheria, DTP. Let's see. Yeah, that's pretty much it. Recombinant antigen vaccines, grown in yeast, induces humoral immunity, which is your B cells. Toxoid vaccines, they're exotoxins, diphtheria, tetanus, and acellular pertussis. They're difficult to make in high quantities, which is why they're not used as commonly. And something about cloning. Conjugate vaccines. I'm pretty sure this is, I'm actually not sure what this is, so we're gonna come back to that later. Conjugate polysaccharide vaccines. Oh, this is the one with the protein bit added maybe. But the virulence factor of many organisms is polysaccharide alone. This was supposed to be a short video, sorry. But yeah. Vaccines. And now I'll eat dinner because it's almost 10.